Hey guys, I'm Tyler, and today we're going to be talking about Tundra lift kits. I'm going to show you guys some diagrams. This is what the front suspension of a first-gen Tundra is going to look like. This specific one shows the lower ball joint, which is a very important component. It attaches the control arm to that hub. There's your coilover, there's your upper control arm, and this diagram just kind of shows what you're looking at for the front suspension. You can see the CV axle poking out right here. Basically a strut, or some people refer to this as a coil and shock or a coil over. Shows expanded, what you're dealing with, the upper mounting, the lower mounting, the shock absorber, as well as the coil spring and how that all goes together. What's important to remember here when we're lifting a Tundra, look at this front suspension, it's all connected. The spindle to the upper control arm, the lower control arm to the lower ball joint. So when we lift a truck, this entire geometry changing. The lower control arm is going to be at a new angle. Upper control arm is going to be at a new angle. The CV axle is going to be at a new angle. All the linkages are going to experience slightly different stresses when you lift the vehicle compared to a stock geometry. Making that coil and shock assembly taller is going to change how all of these components sit. There's three main methods for how you're going to lift your Toyota Tundra. There's suspension spacers. These are very cheap. They're very straightforward. They're fairly easy to install. They're pretty great for on-road use because what you're doing, you've got the stock spring rate and you're just pushing that coilover down. What you're basically going to be doing, most spacers are going to go above the shock body. So you'll still get lifted geometry. You will not affect the spring rate in the front of the truck. You'll have pretty good ride quality that way. I don't recommend them because for one thing, if you have a spacer lift, your bump stop is no longer going to be the limit of your up travel, so there's more wear and tear on your shock body, and in some cases the shocks snap near the mount where there's a weld. So if you're off-roading, a spacer lift really isn't the way to go, and a spacer lift will not increase your ability to carry load. So if you put a front bumper on a suspension on a spacer lift setup, you're going to experience significantly more sag than if you went with a stiffer or taller spring in a suspension lift with a new spring or coilover assembly. Next setup here is the most popular one by far, which is swapping in a new spring or fully adjustable coilover. Like a 5100 with stock springs and just preload that stock spring. 5100s with an upgraded coil spring like an OME spring. Eibach and Dobinson will offer similar setups to that. Or you can go for a fully adjustable coilover. King, Icon, Fox, Radflow, ADS, Sway Away, Toy Tech. Those are some of the big companies. Ones that I wouldn't recommend are like Rough Country. Their N3 strut is a pre-assembled lift strut, but the bushings are typically pretty bad on it. It's very cheap, but the bushings tend to go bad. Usually 5100 with OME springs is about the cheapest you can go. It's not the absolute best in terms of off-road in terms of durability, but it is an upgrade from stock. You want to go above about 2 inches or 3 inches, which is about the max that you can get with just a basic strut or coilover lift. You can get a bracket lift. RCD, Race Car Designs, and Tough Country both offer a bracket lift. It drops the entire front suspension down where the lower control arms mount. So it drops that down and then stacks a big spacer on top of the strut so that you basically keep stock geometry. You also have longer spindles so that the upper control arm can still ride at normal stock geometry. You can also add a coilover of some kind, and then you'll end up at about 5-6 inches of lift. But the big thing to note when you look at the front suspension is that there are limits to how much angles all these different parts can handle. So for example, the CV axle, really the sweet spot on those is no more than 1.5 to 2 inches of lift. If you want your CV axles to still last a long time and not be under a lot of stress, and not have components wear out all the time, whether that be the boots, the actual axle joints, you should stay closer to 2 inches. Those are the three basic methods. By far the most popular is the coilover, the strut assembly lift. So let's talk more about that and more supporting mods that you're probably going to want to consider. The first big consideration is upper control arm. For example, on my lift, I have about a 1.5 to 2 inch lift, and I don't need new upper control arms. My alignment tech was able to get the truck within spec without adding new upper control arm. Many people will need upper control arms in order to get their vehicle to align correctly. The problem you run into with the Tundra is that you're going to need more caster as you start to lift it. Eventually what happens is you need an upper control arm that adds caster to your suspension. SPC, you can adjust even more kind of in terms of where you can move the upper ball joint to hit other alignment specs. SPCs are really common on guys who are trying to fit 35s with as little frame chopping and as little wheel well, bashing as possible and trimming. Now you can also get fixed ones like JBA, Freedom Off-Road, Eibach has them. Yeah, Freedom Off-Road, JBA are two of the big ones just for regular upper ball joint. You can also get Uniball upper arms. So those like Camberg, Solo Motorsports, Total Chaos. Uniballs are more of a race application. They're higher maintenance. They are going to give you more suspension travel in total, but it's a high performance, high maintenance option that's generally more expensive to get your hands on and more expensive to maintain. So I recommend probably JBA. That's what I would go with. If I needed arms on a budget, I'd get the JBA ones. So the lower ball joint's important in the sense that if you do not maintain your lower ball joint, it will fail and will fail catastrophically. I've shown this in other videos that I have, but you should get OEM LBJs. If you don't, the failure is catastrophic and you're risking injury and death. A lot of people will add extended sway bar links. This is something that may improve your ride quality. So a strut shim spacer is often used on the driver's side. People have noticed that the Tundras, when you lift them, the driver's side will drop lower. So about a 1/4 inch spacer on that driver's side is pretty common to correct the driver's side lean. CV axles and boots. If you lift too much, these will wear excessively, but even in like the 1.5 inch range, you can still run into issues. Just get new axles once your boots bust. Or you can add Porsche boots, basically higher, like extended high angle CV axle boots, basically. Differential drops, these aren't necessary, but some people do them. You can drop your diff if you're really worried about your CV axle angles. Bump stops, so like I mentioned with the spacer lift, that would be a time to extend your bump stops. People also change out their bump stops to affect ride quality. If you can get a smoother, more progressive bump stop, like a Duro bump, that will change your ride quality when you bottom out. You don't need to change them out when you swap in a new coilover assembly, but you certainly can. If your suspension bushings are worn, or if your upper ball joints are worn, if your lower control arm bushings are worn, if anything's worn in your suspension, this will all affect ride quality, and this will affect the longevity of your other suspension components, as well as how easy it is for your vehicle to be able to be aligned and keep alignment. So it's important that your entire front suspension is in good condition when you're modifying it. Otherwise, you're going to exacerbate some existing problems while maybe introducing new ones. For alignment, some people believe that these trucks have a hard time holding an alignment when you take them off-road regularly. Mine has not had any issues yet, but if you are worried about that, there are options for cam bolts that can be squared off. These are what they look like. They're pretty straightforward, and they allow alignment to be held basically no matter what. The bolt's not slipping when it's squared off like that. Real quickly, we're going to go into rear suspension now. Rear suspension's a little bit more straightforward because you've got a straight axle back there. You're not worried about alignment or anything like that. The main things are you can add more leaf springs. You can add a leaf. You can get kind of an expanded pack, or you can get a full new pack from someone like Deaver. Give you a brand new entire pack. It's pretty straightforward there. You can also add a block. That's pretty cheap. You add too tall of a block, you risk axle warp, which is basically where the rear axle wants to torque back because the suspension isn't close enough to the actual axle. It's kind of a complicated problem. Add-a leaves are pretty cheap, so really I wouldn't go for blocks if you can help it. Putting in more leaves will increase your weight capacity as well as lifting the vehicle. It should handle weight better when you add stiffer springs to your leaf pack. For rear shocks, pretty straightforward. Most commonly, people just match whatever they have in the front. Or if you're just leveling the truck, you can leave the entire rear end stock. The front is really where there's a lot of decisions to be made on how you want the truck to work, and the back becomes more important if you're towing or hauling often. But if you're just leveling your truck, you may not have to touch the back at all. Big reason that a lot of people lift their truck is because they want to affect tire fitment. They want to fit larger tires. Now, what I want you to consider is, as we've seen in these diagrams, no matter what you do that front suspension, if you're sticking with basically stock components, if you're not changing out your lower control arm for a long travel setup, your upper control arm isn't going to really give you any extra travel. If you're sticking with that kind of setup, no matter what you do to the suspension, it will not affect the size of the tire that you can fit, at least in terms of full suspension cycle. At ride height, it will look like you can fit a bigger tire. But as soon as you go off-road or you hit big bumps, that tire is going to go all the way up into its normal amount of up travel, and it's going to hit whatever interferes with it up there. If you can't fit a tire stock, you're not really going to be able to fit it lifted either. You'll have less trimming to drive around day to day, but ultimately you're still dealing with the same suspension travel unless you do something like a long travel suspension or you add longer bump stops so that you limit your up travel, which I don't recommend. Most people kind of overdo it on tire size because they don't understand that concept. You can still fit 33s or 35s on these trucks and cycle the suspension fully without the tire hitting. You just have to do more trimming than you might anticipate, as well as chopping into the frame possibly. If you want to add a wide tire, like a 12.5 wide tire, you're probably going to have to give up on stock wheel. There's not a golden spec or setup on the Tundras. I did a lot of research on this. I have a big Excel spreadsheet of a bunch of setups that I pulled off of Custom Offset's website. But basically, after all my research, what I generally found is a good sweet spot for a Tundra. If you want to just guaranteed fit any tire, you should shoot for a back spacing of 4.5 inches. Now, back spacing isn't a spec that most people are familiar with. More people would be familiar with offset. Not all offsets are created equal. Negative 44 offset on an 8-inch wide wheel is a very different fitment spec than a negative 44 offset on a 12-inch wide wheel. 4.5 back spacing on an 8-inch wide and a 12-inch wide wheel are going to represent about the same fitment in terms of where the inside edge of the wheel sits relative to the upper control arm, which is the main thing that we're worried about rubbing against. The most common problem that people run into is that the tire rubs on the upper control arm. So to avoid that, I recommend getting a wheel that has 4.5 back spacing. You can find and calculate back spacing on tiresize.com. They have a great calculator so you can compare different wheels. Some setups that don't work that I've noticed. So I've noticed if people add the 4Runner or Tacoma, like the late model 6-spoke wheels, and then just add kind of a slightly larger and slightly wider tire, they're having issues with it rubbing on stock upper control arms. Probably 33s on stock wheels will usually rub your UCA if you go wider than a stock tire. So for example, my setup is a 31.8-inch tire, which is like 1.5 inches taller than stock, 1 inch taller than stock, but it is skinnier than the stock tire. I went from a 245 to 235. So with that, I can go straight up about as high as I want to, and it's not going to rub the upper control arm. But if you're trying to fit a 33 by 12.5 tire, you're going to need that wheel pushed out a little bit further. So you can add wheel spacers to your stock wheels, or you can get aftermarket wheels that hit about 4.5, maybe even 4.0 back spacing. Stock wheels being closer to 4.75, 4.8 back spacing, you're going to run into fitment problems if you go too wide on your tires. Lastly, I did mention long travel. So there's some long travel companies, if that's the route you want to go, whether it's pre-runner, 4-wheel drive, long travel, whatever you want. MCM Fab, Total Chaos, Camberg, Solo Motorsports, and Dirt King all make long travel kits for these. RCV makes extended axles, so if you want to go long travel, that is significantly more expensive. There's a lot of fabrication and parts costs and install costs associated with that. Something to go think about with tire size. So a lot of people go for 33s or 35s. I personally, my philosophy, especially for overlanding and road tripping and stuff like that, is to go with the smallest tire size you can stand. So for me, that was just below 32 inches tall and a very skinny tire. This means it's light, it tracks really nicely on the road, it does better in snow, and it's overall less wear on the drivetrain. It keeps the shift points on the transmission about the same as stock as much as possible, and it means I don't have to re-gear, and I'm not hauling a bunch of extra heavy weight in the tires, which there's not a lot to be gained, in my opinion, by going to super large tires unless you're using your truck in super extreme conditions. Because the difference between a 32 and a 33-inch tire is only about a 1/2 inch of ground clearance. So if you're really willing to sacrifice your MPG, your drivability, your shifting, your overall drivetrain wear and load just for a 1/2 inch of ground clearance, I'd expect that you'd be using your truck for some pretty extreme stuff. And the less aggressive your overall wheel and tire setup is, the less trimming you have. A big question people have with wheel and tire setups on trucks is, how much do I have to lift it so that I can fit X tire size with no rub? And that is ultimately a silly question because it ignores the fact that the tire will still travel upward into the wheel well when you hit bumps, and that will change how much trimming you need to fit a tire. And every wheel setup is different. Just because one offset works doesn't mean it'll work on yours. Offset does not carry over from wheel to wheel, and tire width changes. So every time you change the back spacing or the offset, which are connected, the tire width, the tire height, even just the same tire sizes from different brands will have slightly different characteristics in terms of actual width and actual height. Changing your tire pressure changes how stuff is going to ride. There's no silver bullet to figure out what the best Tundra setup is. You're going to have to do your own legwork and research to really understand what you want. The stiffer the spring, the worse it's going to ride. Right? The higher you lift it and the less down travel you have, your ride quality is also going to go down with it. That's why I advise minimal lift, smaller tires, so the truck still handles basically like stock, and is just slightly beefier suspension and slightly better tires. There's no point in clapping out your truck's suspension, killing the ride just to have it look a certain way. These are great trucks, so my philosophy with modifying them is touch as little as possible, because Toyota really made a good pickup in the Tundra, and I don't think there's a lot that actually needs to be changed on these. And the more you change, the more compromises you're going to make. The higher you lift it, the bigger the tires, you're going to run into more problems the more moving parts you add to these vehicles. So keeping it simple keeps it reliable. That's my thoughts on this topic. Thank you guys so much for watching. Be sure to leave a comment. Let me know if you have any questions, but otherwise I'll catch you in the next video. Thanks, guys.